So, in last couple of classes, we have studied watt meters and energy meters. Okay. So, in this video, in this class, we will talk about connection of watt meter and energy meter in three phase lines. Okay. So, this will we will also do some recapitulation. Okay. So, essentially energy meter and watt meter they have some commonality between them. So, energy meter or a watt meter is functionally a black box which will have two inputs. Okay. So, a voltage input can, so this can be the voltage input. So, we call this the pressure coil, and so you have to connect the voltage, you have to apply some voltage across it, and there will be another coil which will sense some current I. This we will call the current coil, and this is common for both energy meter and watt meter. For energy meter, okay, first for watt meter, the reading, so the reading of the watt meter is proportional to the average value of the product of this current and this voltage. Okay. So, if we apply a voltage V, okay, then the current that will flow through this is V divided by the impedance of this circuit, and if we pass some current I, then the reading is proportional to the average value of Vt It. This is power. And for energy meter, the reading will be proportional to the integration of this product over time, which is the energy consumed within this time. Okay. So, essentially both of them are quite similar. The only difference between them is that, so both of them take the product of V and I. The watt meter, after taking the product, calculates the average, and the energy meter, after taking the product, calculates the sum. This calculates the average, this calculates the sum. That is the difference. So, the connection of an watt meter or an energy meter will therefore be similar. So, the connection of watt meter and energy meter is always similar. Okay. So, if I have a single phase, let us recall. So, if I have a single phase supply with a load, okay, then if I want to measure the power consumed by this load or delivered by this source, okay, we will take the watt meter or the energy meter. If you want to measure power, then watt meter, else energy meter. So, it will have two coils just like this. Okay. Now this current coil, this you connect in series, and this you connect across like this. Okay. Ignoring the small error due to this the fact that the voltage measured by this is right now the sum of this voltage drop plus this voltage drop. So for now let's ignore the small drops or the errors that we have discussed in detail. So for now ignore that. So for that we can have compensating mechanism, compensating wattmeter. So this is ignoring for now, ignoring the small connection errors. Okay. So for now, for the ease of understanding, you are ignoring small errors. Okay. But those are there, definitely there. Okay. Now suppose I have, okay, this is PC, pressure coil. Okay. Now suppose I have a 3-phase supply and a 3-phase load. Okay. Before, okay, there is another important thing I must mention, which is the reading of a wattmeter or an energy meter can be either positive or negative depending on the connection. Okay. So for example, if this same circuit, okay, I connect it. So let me just give some names. Call this terminal 1, 2, 3 and 4. Okay. This is terminal 1, terminal 2, terminal 3 and terminal 4. Now if I had connected possibly like this, so this is the wattmeter, this is terminal 3, 4, 1, 2, this is pressure coil, this is the current coil. Okay. So I have just reversed the terminal 1 and 2. Okay. So now if previously the current was like this, so it was flowing from terminal 2 to terminal 1, now this current is flowing from terminal 1 to terminal 2. So in the current coil, the direction of the current is changed. Okay. So therefore and this current is in the same direction, this current is in the opposite direction, this current is in the same direction. So the torque, deflecting torque will be in the opposite direction, and therefore if this reading is positive, then this reading will be negative, or if this reading is negative, then this will be positive. So these two will have opposite signs, will have opposite sign of reading. Okay. So sometimes we may have a wattmeter which whose dial, whose pointer can move say only in one direction. Okay. It cannot go to the other direction because there may not be any room for the pointer to move to the other direction. It can move only in one direction. Then if we connect the coils in a manner so that the reading is negative, the pointer will indicate 0. Okay? And in that case we have to reverse the connection so that the pointer now indicates positive reading only. Okay? So that is important, and so sometimes the pointer cannot go to the negative side, and there is no place to go to the negative side, and then the pointer gives only 0, and therefore you have to reverse the connection of either the current coil or the pressure coil. Sometimes we have a symbol. Okay, so sometimes we have a symbol on this pressure and current coil, indicating how to connect. And this symbol and convention, this can vary. Different instruments have different conventions. So do not memorize this thing. This is only for our knowledge and common sense. The most important thing I was saying in engineering, common sense is common sense. Okay. So sometimes I am just giving you an example. Do not memorize it. Okay. So wattmeters can have marking like this. So if these are the two coils, pressure coil and current coil, so they may have a plus minus sign on this side, on one side of the pressure coil, and a plus minus side on one side of the current coil, indicating that if you apply a higher voltage on this side compared to this. Okay. So if this voltage, say if this point is at 5 volt, this DC for ease of understanding, this point is at 3 volt, okay, then that means current is actually flowing like this. And at the same time, if you connect this coil in such a way that current also flows through the entering through this symbol, leaving through the other terminal, and here this symboled marked side is positive, then so with this connection the reading will be positive. The reading is positive. Okay. So if you connect this meter in an opposite way such that you have 5 volt, 3 volt, but now the current is going in the opposite direction in this coil, entering through this side and leaving through this symbol side, then we will have negative reading. Okay. So if this is 5 volt, this is 3 volt, but current is entering through this, we will have negative reading. Similarly, say if we connect like this, so that this current is entering through this, so I am using now blue color, and say this side is at 2 volt and this side is at 3 volt. Okay. That means this is at higher potential, then this will give negative reading. Okay. So sometimes this type of conventions, this type of symbols are used. Once again, do not at all try to memorize this thing. What I will suggest you is that whenever you see a new instrument in your lab or in your workplace, try to see, are there any symbols? Is there any manual? Go and read the manual. If there is any symbol, apply your common sense and try to understand what they may mean. Do some small experiment, apply some known voltage and current and see whether the pointer is moving to the positive direction or to the negative side. Do some small experiments before you put that in use. Or if you are in a job, so you have other people who also use the same instrument, go and ask them what is the convention, how to connect it so that it gives positive reading. Do not memorize anything, apply your common sense, read the manual, ask other people, to your seniors, to your instructor, like that, but have the common sense, that is important. Okay. So, now let us move to 3-phase wattmeter connection. Okay. So, for now, for ease of understanding, I will once again I will ignore the small connection errors which we discussed before due to non-zero current coil resistance and non-infinite voltage coil resistance. Okay. So, those small errors we will ignore now, and we will also I may sometimes forget this plus minus convention, etc. So, ignoring these small facts, let's see 3-phase wattmeter connection. So, 3-phase wattmeter, for that we need a 3-phase load and a 3-phase supply. Say this is a 3-phase supply and there is a 3-phase load which is like this. Let me take a star connected load, it can also be a delta connected load. Okay. So, it will be connected like this supply to this phase, this to this and this to this. Okay. So, this is a 3-phase supply. Okay. Let me also draw a generator, 3-phase generator. And this is a 3-phase load. Now, we want to measure the power consumed either by this load or supplied by the source, which will be approximately equal if we ignored the small losses elsewhere in the line, in the meters that we will connect. So, we will ignore those small losses. Okay. For now, we will ignore. So, now to measure this total power, what we have to measure? We have to measure the product of this voltage and the current through this. Okay. So, let us give some names, phase A, phase B, phase C. Okay. So, this current I will call IC, this current I will call IB, and this current IA. And the voltage, so if this is the neutral reference point, okay. So, this is the reference point, as this is also you can think as the reference point, ignoring the drops in the line, etc. So, this is a 3-phase 3-wire. So, this is a 3-phase 3-wire connection. Okay. Now, we can also have a neutral. So, this is the neutral line. Okay. So, let us start with this 3-phase 4-wire first. Three phase 4 wire connection. We want to measure this power. Okay, so what we have to do, once again, this current times this voltage. Which voltage? This voltage, Vc. Okay, and I can put a plus minus sign. So this indicates the chosen reference for measuring this voltage. Okay, so similarly, this is Vb. Between the neutral and the B phase, and similarly we will have here Va between the neutral and the live phase A. This is plus side, this is the reference minus side. Okay. So now to measure these three powers, I can use 3 wattmeters. So let me take 3 wattmeters. So this is wattmeter 1, and so with this I will measure, say, the power in this phase. Okay, so it will have 2 coils. Okay, so I have to measure this current and this voltage. Now to measure this current, I will disconnect this and put this current coil in series. So this is the current coil, CC, and the for the voltage coil, let me put the voltage coil across this live C phase and the neutral. Okay, ignoring the small current going through this pressure coil once again. Okay, ignoring those small errors, and yeah, and okay. So this is 1 wattmeter which will measure the power consumed by this. Call it W1. Similarly, I can have another wattmeter, say W2. It will have 2 coils once again. Let this be the current coil, and I want to measure the power consumed by this. So what I do, I open it, connect it here like this, and this is the pressure coil. So I want to measure the voltage from here to here. So I put one side to the neutral, another side to this. Okay, so now similarly I want to measure the power in this A phase. So let's take another wattmeter, call this W2, call this one W3. Okay, so another wattmeter, this is current coil, let this be the pressure coil, this is W3. Now the current coil I will insert in series to measure the current IA, and this I will insert in parallel. So one side to the live, another side to the neutral. Okay, so I can connect it here or maybe here to this neutral side. Okay, this is the neutral line. So this is the three phase 3 wattmeter method. Okay. Now there is another method which is called 3 phase 2 wattmeter method. Okay. Now let's see another method which we will call 3 phase 2 wattmeter method. So let me draw once again the source 3 phase. So this is the 3 phase source, and let me draw a 3 phase load. Now this time we should not have the neutral. Okay, we do not have the neutral line. So, this is important. This is very important. We should not have this neutral line in this method. And now, the way to connect the two wattmeters is as follows. Okay. So, we will have two wattmeters. Now, the two wattmeters are like this. They will have their current coils and the voltage coils. Call this current coil, voltage coil, current coil, voltage coil. Okay. So, what we have to do? We have to measure the current in two phases. Okay. So, there are three phases, three lines. We have to measure two line currents. Okay. So, we have to measure two line currents. So, say we are going to measure these two line currents, this one and this one. So, we are measuring these two line currents, call it IA, and if this is A, this is B, this is C. Okay. Then this is IC. So, you are measuring IA and IC with two wattmeters, and the voltage coil, they will measure the voltage between the corresponding say line. So, this is measuring line current in phase so C, line current C. So, we will measure the voltage between C and the unused, which is the B, the unused line. So, this will measure the voltage between the corresponding line and the unused one. The corresponding line means here it is C, the current coil is in C phase, and the pressure coil therefore will go between C and B, which is not used. Similarly, here also this should be connected to this, one side to the corresponding line, another side to the unused line B. Okay. This is how to connect. So, this is a 2 wattmeter to get the power measured in these three phases. So, now if I call this W1 and this W2, then W1 plus W2 with appropriate sign, with proper sign, okay, their reading can be negative, gives total power in three phases. Okay. So, previously in the 3 wattmeter method, to get the total power we needed W1 plus W2 plus W3. So, here W1 plus W2 plus W3, this was the total power. Now, in this new circuit, W1 plus W2, this will give the total power. How? Is it not surprising? The previous one was quite obvious, because this wattmeter was directly measuring this voltage into this current. This was also measuring this voltage into this current. So, they were measuring individual phase powers. So, that this was quite obvious. But now, how is it so that W1 plus W2 is the total power? What this wattmeter is measuring? This is measuring this current multiplied by this voltage. What does it give? I mean, what this is equal to? Okay. So, let us understand how is it true that W1 plus W2 is equal to the total power. Okay. Now the reading of W1, okay. So W1 plus W2, now W1 is the reading of W1. So W1, we can write this as this current IA multiplied by this voltage, okay, which is VAB, voltage between A and B. So this is W1, okay, and W2, this will be this current IC multiplied by this voltage C2B. Okay. Now by this I mean VAB means voltage of A minus voltage of B. Plus, here we can write IC multiplied by VC minus VB. Okay. So then what we have? We have IA VA minus IAVB, this term, plus ICVC. Okay. What is VC or what is VA? VA is basically the voltage from here to here, from this point to the neutral. So this is the reference point, 0 volt. This is VA, this is VB, this is VC. Okay. This is 0 volt, this is VA, this is VB, this is VC, and VAB is this voltage from here to here, okay, with this side taken as the positive reference, this side as the negative reference, because we are subtracting VA minus VB. So VAB according to our chosen convention is VA minus VB. Okay. So yeah, so there will be one more term, IC VB, right. So now let's rewrite this as IAVA, this, then this term I will write plus IC VC, and then these two terms, this and this, I will write together. So see, VB is common, so I can write minus VB common, then IA plus IC. Okay. Now we can write in place of IAIC, we write this as minus IB. Why? Because since IA plus IB plus IC is equal to 0. Because we do not have the fourth wire, we do not have the neutral wire, therefore the sum of these three currents should be 0. This is KCL. So this is the KCL. And therefore IB is nothing but minus IA plus minus IC. So I can write it like this. So therefore then this becomes IAVA plus ICVC plus IBVB. This is the power in this phase, this is the power in this phase, this is the power in this phase. So this is the total power. So you see the magic or the math, that we have only two wattmeters which are reading these two quantities. Okay. So remember how to connect the two wattmeters. This is something you have to remember. Okay. There are some things that you have to remember. How to connect it. Connect two current coils in any two lines, and connect the two voltage coils between those two lines and the other unused remaining line. So this is, so remember how to connect it, and then this derivation is straightforward. Okay. Okay. So this is called 3-phase 2 wattmeter method. And will this method work if we have the neutral line? So, question, will this method work for 3-phase 4-wire connection? Think. And now I am giving you the answer. The answer is no. Why? Because if I have the 4th wire, if I have a 4th wire, okay, then IA plus IB plus IC will be same as the IN, the neutral current, which need not be equal to 0. Not necessary that this is 0 if I have a 4th wire. If I do not have the 4th wire, then there is no 4th current. So, then this is of course 0, then this derivation is true. But if I have a 4th wire, then this is not true. But yes, of course, you may say that if the load is perfectly balanced, then even if we have a neutral wire, then yes, then this method will work. But if there is any unbalanced load, any unbalance between these loads, then with the 4th wire, this method will not work. Okay. Now, of course, last small thing before I conclude, but this is once again a bit more detail, which you may ignore, but this is required in practice. So, let us go back to this convention of plus minus. Okay. So, suppose if these meters have plus minus signs beside their current and voltage coil, then how should we connect it? Okay. So, we should connect it in such a way so that if the plus minus side is here, okay, then I should have the plus minus sign here, okay, because I am measuring, see, this current in this derivation also, you see I am measuring this current and the voltage VA minus this is for this wattmeter. So, I am measuring this IC and VC minus VB. Okay. So, if IC is now positive, you also see this VC minus VB is also taken like this. I mean, so if I have this plus minus sign here, let me repeat in a different language. If I have the plus minus sign here, then this is this coil is measuring this voltage minus this voltage, which is VC minus VB. And similarly, if I have this plus minus sign here, it is measuring this current IC. If I by mistake had the plus minus sign here, then it is actually measuring minus IC. So, the reading of W2 will be opposite than expected. Okay. So, this should be here. Similarly, think of it, if I have say the plus minus sign here, okay. So, the current is entering through the plus minus sign according to the chosen reference. Here also I should have the plus minus side on this side, okay, from this to this. So, that this is measuring VA minus VB. Why this is so important? Because in 2 wattmeter methods, as I already have mentioned, this W1 plus W2 with proper sign, with appropriate sign, only gives the total power. Okay. So, the reading of these meters can come out to be negative. Okay. If you connect in this way, the reading of this meter can come out to be negative. That will depend on a lot of things like the angle of the load angle of these loads. Okay. So, this can be negative. If it is negative, you have to add W1 with that negative value only. Okay. So, we will take some examples in a in another class. So, therefore, this plus minus sign is important. How I have decided this plus minus sign? Summarizing again, I am taking here W1 to be IA times VA minus VB, and if I choose IA in this direction, okay, from left to right, then I should have plus minus here and VA minus VB. So, I should have plus minus on the VA side, positive side, and nothing on the other side. Okay. So, we can have other symbols instead of this plus minus. So, think of this, and as I do, I put the reference sections from which you need to study these things in the book. So, in the book also you check these symbol conventions and these small details. Thank you.